Okay, so I want to prove to you that this equation that we've been working on is the exact same thing as we saw before with our resultant force on a beam. So in this case, the example we're looking at is simply saying, okay, I've got a whole bunch of masses. Masses are proportional to weights. We're not going to bother to multiply by gravity because we only want the centroid. And we know that the mass acts at the centroid of each of those shapes, which, luckily for us, the rectangular boxes, is the center of each of these shapes. If I want to find this resultant place, the center of gravity, where all of these weights, well, these are masses, but their weight will be acting, then I have to take the weighted average, which is exactly the same as our resultant force equation. Okay, it's exactly the same. So let's try it out. I'll write it down as our old equation, like for resultant force in the x direction. I'm silly. Centroid in the x direction is going to be equal to the sum of our forces times their little x squiggly hat. And I'll just leave it as f. There we go. All over the resultant force, which is going to be resultant force in the y direction. Okay, now let's give it an r. So if I do this, I'm looking for this resultant r. I know what it is because I just have to add all the masses together, which would give me force if I multiply them by gravity. I'm not going to do that just to save myself some time. So let's first add them all together. So r is going to be equal to 500 plus 350, okay, plus 200 plus 800, okay, plus 700. This is equal to 2550 kilograms. Cool beans. Now, the second part is the sum of the forces, in this case the masses, times x bar. So I do that. And I'll go ahead and write over here because it's going to be a lot of writing. Now remember, this is always to their individual points. So it's 2 meters for this first one, 4.5 for the second, 6 for the third, all the way down. We have to look at where their centroid is from the same point. If you measure from different points, it doesn't work. You have to measure it from the same point. Now it doesn't matter where you measure it from. Like I could measure everything from here. I could, even if I wanted to, measure everything from here. It doesn't matter where you measure it from, but everything has to be measured from the same point. You have to make them either negative or positive based on that. Okay? Negative or positive based on that. So let's try it out. Let me erase this line right here. So what I get then for my sum of the forces times their centroid is I get 500 times 2 plus 350 times 4.5 plus 200 times 6 plus 800 times 8.5 plus 700 times 11.5. And I divide that by the total mass, which is 2550. And from that, what I get is that my centroid will be equal to 7.3 meters from this left point. 7.3 meters. I'm done. Now, I wrote this kind of strangely here, but I could have written it in a more reasonable way. Just that my centroid is equal to the sum of the masses times their little x centroids all over the total mass. That's another way I could have written it, and this is always going to work here. You're going to see this a lot for the centroid, for area, for mass, for weight. Whatever it throws at you, volume, it still works. The same equation works over and over and over again. So, thanks for listening, and I'll see you all next time. Goodbye.